Good morning, students. Welcome to the physics class. Today we are going to start a new chapter that is termed as the gravitation. So you already studied about the meaning of gravitation in the lower classes. So let us go for the introduction to this the gravitation. Before we go into study about the actual meaning of the gravitation, let us understand the gravitational force of water, Earth. If we throw any object upwards, it comes towards the water, Earth. If we release a small stone without pushing it from a height, it accelerates towards the water, the Earth. The stone is when accelerated towards the Earth, it means that some force which is acting on it. The force which pulls the object towards the center of the Earth. So you already know that is termed as the gravitational force. The force which acts towards the center of the Earth is termed as the gravitational force of the water, Earth. So here the stone also attracts the water, the Earth. Not only the Earth attracts the stone, but the stone is also attracts the water, the Earth. Then what you call for this? Then what is the meaning of the gravitation? The gravitation is not only for the water, only subject to the Earth. It means that the gravitation is related to each and every object in the entire universe. Each and every matter, each and every particle, the gravitation exists. So it means that what is the meaning of this gravitation? The gravitation is nothing but it is a natural phenomenon. It is the fundamental force of attraction between the two big masses or the two masses. It is an attractive force between the two masses is termed as the gravitation. Two masses means it may be a very big or it may be a very small. So here is one example. The gravitation keeps the Earth and other planets in their orbit around the sun. So there is so many examples are there like this. The gravitation between the water, Earth and the moon, Earth and also the sun. Each and every object in the universe, that is what we termed as the gravitation. This gravitation is discussed in 1687 by the Sir Isaac Newton. Proposed the many laws here about the force of attraction between the two objects in the universe. So that is well known as the Newton's universal law of the gravitation. Each and every object in the universe, there is a presence of the gravitation. There is a force of attraction. So the meaning of this gravitation is that gravitation is the natural phenomena. It is the attraction between the two big objects or two big masses is termed as the gravitation force. The gravitation is also always attractive force. Now let us pass on to what is this the Newton's universal law of gravitation. So here we have Newton's universal law of gravitation. Consider here is the one mass let us call Earth, and here we have a moon. So I mentioned this the m as a what here, in a capital letter, and another mass, the m is in a what here, the small letter. There are two masses are there, m and m, or we can say m1 and also what is that, m2. Now we have the force of attraction between the two masses, that is termed as an F1. F1 is the force of attraction towards the what here, F2. This is the force, and F2, this mass m, is attracts the what here, F1. Okay. According to the Newton's laws, you already know that F1 is equal to minus of F2. So we have already discussed that Newton's third law of motion. The distance between these two objects is considered as what here, the r. M and m are the two masses. R is the distance between the two masses, and F1 and F2 are the what here, the force between the what, the two object, or force of attraction between the what here, these objects. Now the force is always directly proportional to the product of their masses. Directly proportional means what? As the masses goes on increases, the force of attraction is also goes on what happens, it increases. So therefore the force is directly proportional to the product of their two masses. Therefore, I can able to mention with the what here, the one equation, that is the F is proportional to m and also m, and it is inversely proportional to what here, the distance between them. Distance between them, I can able to mention the force is inversely proportional to what here, the square of the distance between them. F is inversely proportional to 1 divided by r square. Then if you combine these two things, the force is directly proportional to the product of their masses, and force is inversely proportional to the square of the distance between them. If you combine these two things, what we will get is the force is directly proportional to the product of their masses and inversely proportional to what here, the square of the distance between them. So that is r square. So this particular equation we will get. So if you remove the proportionality sign, what we will get? We will get a one constant, that is termed as an what here, g. Then what is this g is called? The g is considered as a what here? It is a constant termed as an universal gravitation. It is a gravitational constant. So universal law of gravitation is tells you about that. Can you able to what here, the state the water, the law, universal law of gravitation. Every the mass in the entire universe attract the each and every mass with the force is directly proportional to the product of their masses and inversely proportional to what here, the square of the distance between them. So he is termed as an what here, universal law of gravitational force.